I'm trying to limit the step size here to twice the value of the scale. I thought I still crashed though. It apparently doesn't work. I should probably delete this. That was a bug fix. Another bug fix. More bug fixes. Okay, let's do an add for stuff that definitely is correct. I want this color change. Okay. Let's not commit this yet. Definitely not this. Should I remove it? Okay. Oh right, that thing. Yeah. Yeah, but why does that happen? So the problem here is that the approximation here. Approximation uses twice the same sample. You cannot fit something through twice the same sample. Okay, yesterday I couldn't figure out why that happened. I have to fix that first. So that means assigning to relevant samples and then getting twice the same pointer. Should be able to figure that one out, where that happens. Relevant samples, something becomes something. Do that even before you actually assign it. never end up with twice the same symbol. Assert. So a new symbol is added. This is a replacement. Which means we just replace the current index. So that means we did not already have two samples. And if we just have one sample and we replace that one sample, we can never end up with twice the same sample. Or afterwards, we do not have the same sample. So this something else is unequal current. But if something else means the other one from current index. We're going to assign to 0 or 1, and then the other one, which is then 1 or 0, should not already be equal. And in this case, I prefer to do this before we assign it, like I said. So I want to test if we have that. I think I can just test on the number of relevant samples. That's the previous number of relevant samples. So if that is equals to 0, then after this we will have one sample. And then I can do the same thing. The other one is unequal current, must be. And then we have another one. Here, I guess. It's a backtracking sample. This is a recursive call. should be sure what's happening here. Add backtracking, so call backtracking with false. After putting the backtracking sample over the current one. Yeah, I think the number of relevant samples must be 2. Yeah, here. Or 1. Looks like a replacement, so I'm going to say that it is unequal to, or this cannot be equal to the backtracking sample. Yeah, I'm seeing something really weird. That is definitely not good. We should find the extremes. Well, first we go that way. So this one first, and then that one, and then the maximum. Minimum, maximum, minimum, maximum, and then it should find this minimum. But for some reason it goes back and tries to find the previous minimum again. So that's also wrong. Nevertheless, I can't link that you're getting twice the same symbol. Hey Ninja, what's there to yawn? This is hard to debug. So I'm about to override that index with this value. And then we end up with that value both in index 0 as well in index 1, which is definitely undesirable. Why? I mean, what the hell is going on? Let's highlight both values up till reasonable round off. Or this one, that would be a regular expression. And then scroll back until those values start to occur here. So this value is returned first. It's 0.43. It's hard to see where the hell that is. Somewhere close here. Okay, let's just play dumb. Okay, so we get this value for whatever reason. That value is then added to the history. Who cares? And to the approximation. So here we try to add it to the approximation. Then we get a better approximation where the other value, virtual Abhishek, the other the other value is the extreme of the new approximation. Critical point has this value. It's just an event. Cubic. Approximation is cubic. So the 0.36 leads to the 0.44. We have the 0.36 and then we fit a cubic which has then a minimum at the 0.44. Seems that my approximation is not printing the two. Wait a minute, what am I printing here? It's just the event data. This might be the relevant samples here. Pointers to relevant samples. But only because I'm printing it when it's being passed to skill update. It'd be nice to just print it after it got changed. It's part of the approximation itself. Handle event, okay, handle approximation, find extreme, in between, because this is what the required extreme is, the minimum. And now returning to 0.44, which is the minimum of the current fit. And that then is returned. Call that operator again. Backtracking. It's backtracking. Oh, right. Okay, yeah. It's so hard to see here because everything is on top of each other. Now I do have a mental picture of what's going on. Let me draw it. So we have this, let's say, the function, and then I'm having points here initially, which has a minimum here. Oh no, never mind. I was confused with something else. I thought I was suddenly thinking that this was extra data, but it's not. But still. So we find this, and then we say now we fit that thing. So it is backtracking because you go there. So the next point. And then this is being added. Or is it? You know what? I can't zoom in, but I can just restart everything. Having already zoomed in. I want to see, let's say, from -33 till let me see what the previous value was. minus 32. And then the height, say from 1800. Well, actually it should go correct automatically. Because I haven't, yeah, I really want to see what's going on graphically. Yep. Well, if this is backtracking, then I guess the other point that this cubic is fitted through must be on the left somewhere. Should be able to see that. It's just and what is that? Minus 32.36. No, that's 43. That's this point. What about the other one then? Minus 33.447. That would be that one. So I missed it. Neither of these two are going through 44, so I need to extend my debug output, I think. Let's add some debug output there. The other one is at minus 38.8. Yeah, it's a lot to the left. So we're having minus 32. That would be this one, I think. And minus 38, which is just a lot pretty far to the left on this scale. And that gives this cubic. And I think we're backtracking because we jumped from that one to this one. So the 42 is current, right? That should be the one that is mentioned first. Yeah, this is current. So we jumped from here to there. And now we want to go back in that direction. So that would be backtracking. So I think that if now I hit space, it says backtracking. And then now it jumped from 42 to 43, which means that it's no longer backtracking, if you ask me. We should be continuing in the same direction now. George, did you read the description of this video? But in super short, I'm trying to find this minimum here right now, although I'm already found it. By fitting cubics and then jumping to the minimum. So now we should jump to this minimum. Let's see, so I was here, our backtracking, added to the history, and that is 0.43. Update approximation. Adding minus 32. So that was this is the point number 43. It's being added. You're turning in between. Oh, wait a minute. It is still backtracking. Ish. Well, not really, but we just replaced, I think that, so what's happening, we basically have 3 points. So the point at minus 38, the 42 point, and then the point that we jumped to because of this cubic. And then from that triplet, it picks 43 and the point at minus 38, because those two have this minimum. So then the next approximation is using 43 and the point at minus 38 still. And then it kind of, even though the last point was 42, it's still in a mode where it thinks that it was jumping from 38 to 40 for the minus 38 till 43. Oh, it's like we jumped from here to 42 and then basically said that's too far. So now we try to jump to 43. and that's still too far because we have to go back. So it's still backtracking, I think, for that reason. Yeah. So we added new point, and it should have been added such that it replaces, so 43 should replace 42. That's the idea. So the approximation only has two samples. And we had the point at minus 38 and 42, and then it replaces the 42 with a new point. So now we should have minus 32.3 something for this one, and still the minus 38. And that is the case. And the minus 38. And it said the current index is 1. That's not correct. This is the last sample. Was that previous also the case? I didn't see a real serious problem before this. It's kind of strange. Well, I don't know. I would say current is the last one. But that's also not the case here. So it calls this one. Oh no, wait a minute, sorry. I'm confused. It's not 01, it's current previous. So that's a bit, that's not very clear from this debug output. Maybe we should add a little bit more that I know that this is index 1, this is current, which happens to be in the array stored at index 1. So current was replaced here. Current was replaced and the other one was left alone. And well, current is still at index 1. Let's hit space again. Now at the search. So now we jump to the vertex of the cubic through 43 and minus 38. It's still backtracking, indeed. That's the correct value. It's simply added. This should be 0.44, and it is. Entering update approximation with that one. So current index is still 1. And that's the one that should be replaced in my opinion. I have no idea what's going on. So previously we had got an interesting Reddit message, but when I click on it, it's not visible basically. I don't know where I got. I'll read it later. I mean, if 1 is current and that we were replacing that index number 0 must be the minus 38 one. Is that not the case? Doesn't look like it at all. Wait, pointer. Nope. Oh, it was replaced. We lost the minus 38. Well, we should not have. This is very confusing. Definitely should not have. More debug output is required. Well, maybe we should add a watch. I guess I could add a watch on the 0 and the 1W values and then see how they change and where. Once I have an idea of what we should be seeing, but yeah, okay, let's start over. So going to run again until I see 42 being added here. And then going up. Algorithm. I think algorithm is an yeah, current approximation. I'm pretty sure that's the one that we work with, hopefully. Or I could use approximation pointer probably, which would be one step safer. Nope. Well, just without a current in? No, wait a minute. Yeah, without a current. Approximation pointer, which then shows us the approximation, so that thing has relevant samples. and then that has m elements. And that has then m elements 0.w and 1.w. This is how I expected it, right? So current was 1, and then the 0 one contains some minus 38, and that is changed rather unexpectedly somewhere. And now to set a watch point, we need the address for that, or maybe I can evaluate it with this whole expression, but then definitely I need to have a starting point. Again, we can use this, I think. So we can do a watch on that address being used as a pointer that gives me this value. How many braces do I need? So one more. And then in the other one on 1. Exciting, isn't it? Well, of course we're going to stop because I'm watching both. Yeah. So right now they contain minus 38 and minus 32.15, which is here. So I don't know how to call this. Shall I just call this one 41? So we have 41 and 42. Going to hit space. That's all nice and dandy, but I should continue first. Command aborted. Could not insert a hardware watch point 1. Could not insert you may guess too many hardware breakpoint watch points. I don't think so. Okay, that sucks. Maybe this is not how it works. Let me try that again. I think I'll just skip skip the what is it, approximation pointer, because I don't think that changes. Everything should more or less be at the same address all the time. So you need to go up until we are inside algorithm. And then I can print these values. And I'm going to assume, well, I don't, the algorithm is not changing, and I'm going to assume, I mean, that's somewhere on the stack that is pretty fixed. It's in main, so that it won't change the address. And the approximation pointer, I'm going to assume that it just continuously points to the same object, which is a member of the algorithm, and therefore, and the rest is not pointers. So I can just take the address of this thing and watch that. Watch the contents of that memory address. And then that was 0, and then we have 1. Watch the address of the other one. This one. Continue. Now it worked, didn't it? Hitting space. It's okay, but my hardware watch point didn't fire. What the hell, man? So what the hell? What is going on here? Oh, it took forever. Now it says that it changed. What? And this is the change that I did not want to see. None. It looks more like my object at that address was destroyed. This is a random write, but this is not. Huh? The W value? Oh. So this thing is at the previous address. No, still, but it's just nonsense. Well, it is. Wait, it is a sample. Okay, maybe this is the sample. So yeah, okay. My sample at that address, which I was watching, is being changed. Okay, well, okay. But is this still the address in the relevant samples of the relevant approximation? Is the question now. So I can check that. I would say so. So I'm going to go back to algorithm, and then we just print using approximation pointer the address again. Both. Yeah, it is the one address 0. So index 0 is being changed apparently. Here. And that is done by writing to current. And current is Raoul, hello. What advice was that? The only advice I ever give is to just work your off, your ass off. Yeah. The thumbnail, yeah, some things just stick. That is a very, very old profile picture that I use for Colorwood. Very old. I'm kind of attached to it now. Maybe I should show it to one of those graphical AIs and then ask it to redraw it, but then sharper. It's actually an idea to have a new profile picture drawn by an AI. Ah, yeah, right, yep. I remember, and true. You have to You have to stick on any point that you get stuck at. You have to just stick at it. There's no reason to continue until you understand it, and then go to the next step. Exactly what I'm doing here. It takes forever, but that's the way to become a hacker. I mean, hacker as in expert. It seems like, yeah, but then I don't learn anything. But the opposite is true. Fast forward 10 years and you're the guy that everyone goes to ask questions. The top paid hacker of company X. Oh, there is a company X these days. Oh, you get what I mean. If you work hard enough and long enough, then it definitely will be true. Yeah, and make that will automatically happen, I guess. But you have to your portfolio basically for as a programmer is the code that you wrote. So you build up I don't know a source tree with projects, and say you write something that connects to a socket and does a DNS lookup and stuff like that. And then 8 years later, you need to do that again, but a little bit different. It's more modern time, blah blah. You can still go back to that code that you wrote 8 years ago and scroll over it, and everything will come back. And you go, oh yeah, that's what I did. And then in no time you write that new code, which is a good reason also to document everything, of course, meticulously, because you're talking to yourself 8 years from now. Well, honest, when I was in my 30s, the big boss, well, actually, my boss couldn't really deal with me, I think. So the boss of the boss took me under his wing. Was a nice guy. And so I had to come to his office, and he asked me, how come that you are always that fast? Well, the heart of the problem was that I never said how long it would take. I couldn't. So the project leader would come to me and say, yeah, how long do you think this assignment will take? And I always said, I have absolutely no clue. And that was apparently very frustrating for this guy. But then 1 week later, I was finished, and the rest of the team wasn't. So, yeah. They still, then they just let me do my thing, and then I was fast enough anyway, apparently. And I remember that the reason was that I was just using code that I wrote in the decade before that. I mean, I started coding at 12. So in my 30s, I had already a lot of code. And they let me do something that was related to it. I think I got hired because I was a developer and designer behind the Undernet IRC. So they found IRCU and then contacted me, and eventually was hired there. And then they let me do something that was related to networking. So yeah, all I had to do was look at existing code that I had and then put it together again. So that was always super fast. I wish I still had my memory though. So every time I chat with someone, it's last I said I told someone that the idea came to me that like if I'm super deeply concentrated on my program, I can still perform on a certain level. But as soon as I'm distracted by the chat, even for a short time, and I try to return, then my mind is blank. I have no idea what I'm doing here. What am I doing? Oh, I'm in the debugger. What was I doing? So I thought, realizing that, I thought, hey, it looks like that everything I'm doing while coding is in my short-term memory. So now I have the feeling my short-term memory or whatever memory I'm using during coding is shrinking. It's getting slowly smaller. So you have to keep doing it every day and use those neurons, and still it gets smaller. So eventually I will not be able to code anymore because I just don't have enough working memory in my brain anymore to keep track of anything substantial. And I think it has already decreased enormously. I'm also a bit scared that, you know, I could be degrading such that I'm not the coder that I used to be at all anymore. I'm just, you know, someone who nobody would like to pay because my productivity is almost zero. But I myself would not notice it because, yeah, I mean, that's one of the things of getting older. You basically don't really notice it, just vaguely. So I can imagine that. That I would have finished this project a few decades ago. I would have finished it in no time, and now I am hardly having an overview, and it's slowly progressing because of that. If I can only see 10% of the whole project at the same time, the whole thing becomes unmanageable, and I get confused, and I just miss the overview, period. Can't do it. Well, if you have the complete overview, everything falls together, and oh, simple. That's how to do it. I'm not sure, but that's what I'm scared of. Anyway, it's peculiar that as soon as someone in the chat distracts me, that I completely lose what I was doing. So yeah, I don't know, man. Yeah, well, no. Let's go back to coding. I'm going to concentrate for a second again to pick up where I was doing something. The weird thing is that I'm overriding. Oh! Oh, okay, yeah. I think that the overriding this sample here is because my history is a circular buffer. Which means that I think the size of my history buffer is 9. So that point at minus 38 is being overridden because my history is too small. That's what's going on. Okay, problem solved. Now that should normally not happen, but something weird was happening anyway. It went back to a point where you should never have been. Now I'm very curious though which number in the history that was. The minus 38. I guess I can find that by simply highlighting it. Minus 38. Yeah, there. Um, 0.79, right? And then the question is, where does that happen first? Oh, here it is. Returning it. History, adding it, 0.35. So that means that we have only nine history size is 9, so that means that 0.44 would override this. And that's exactly what happens. So we have 43 and now I write 44 and that gets written on top of 35, which is the point at minus 38. Yep. Yeah, that is something specific to backtracking. I just hold on to a point, and while adding new points, all the time holding on to that one point. And that's not good. Well, it's not good if I then override it anyway. How do I solve that? I guess you could make a special backtracking sample that I point to. So it is, as soon as we start backtracking, I copy it from the history to the backtracking location, which then has a lifetime until the next backtracking, which is long enough. Okay, I'm thinking. So the idea of making the copy is good, but then I need to know when to make the copy. not enough comments. What was backtracking sample? I guess it's not the old one, because it's using current index. Current was the new index. Yeah, I'm overriding. It's the one that I'm overriding here. It's definitely not what I wanted. Where are we setting backtracking? Only here, it seems. Only here. Only there. So state is set to backtracking for the first time at some point. And then I already know what the W value is, because I'm setting the expected value here. So we go here and here and here. Okay, and step is initialized from new W value. I might be adjusting it though. Eventually set that here. So what the hell was this set before this point? Oh, because there's a return there. Bro. There's no return here though. To transform handle approximation. So if here state equals backtracking, then I could do something to make sure that the sample, a certain sample, is preserved for a longer time. That gets a longer lifetime. Which sample? I think the previous one. Or I could just return and then have it be handled by some function, which is then entered. Probably this one, update approximation. Handle approximation. It's also using it. But it's setting it, yeah. Never mind. Update approximation. This was a handle approximation, printing. This is the operator parenthesis, and then update approximation again. So this would be called first. And then approximation add is called. We should not be backtracking if this is not true. Oh, that's indeed tested here. So we always get here. So we're entering approximation add with the truest last argument, because we are backtracking. So to get an idea of what to do, I would like to have a breakpoint here. When backtracking is set for the first time after point 35. Probably should do that manually. So let's do that then. I'm just adding it there. VI here. Let's draw the 38 as well. $35. It's already at 0.39, dude. Yeah, but that's because of another bug. So maybe I should ignore that. For now. So then we get so it's 35 is already here. It seems. Yep. Yeah, well, okay. So because we are backtracking, we are going to replace current instead of the oldest one, which means non-current. And then that could happen several times, and therefore the oldest one itself, which is this one, might need to exist longer than it does. So that would be the non-current one. Then I should make a copy of whatever this thing is pointing to and then have it point to somewhere else. And that would be, I think, purely a case of the approximation object. Should be. So I'm going to, I can just copy that one to, I don't know, current object, approximation itself. But if you continue, then we are entering this function again and again with backtracking true. Yeah, I I could keep making copies. It's just 24 bytes. What is better, making a copy of 24 bytes over and over? Well, that is in the cache probably still. Or doing a branch, testing something. But that test is also continuously true then. So probably the last one. The branch is a little bit fast. Tough decisions. I'll do the test, I think. Right, so that would be in this function then. Or is it what did we quit? Yes. And then I need to add a sample to approximation. And then I use a completely random name. Pivot. It's a bit too short. Let's just call it backtracking. Nonsense. Man, what am I doing? What am I doing? Yep, I think this is actually working. Yeah, to make a, I don't know, man. Maybe I should replace this as the same way I did in another class. Moving is a bit stupid, so I'm going to make the copy constructor, but then just private, and then we add I need this one, Baha. No. What am I doing, man? Actually, that will work. Baha. I need a move constructor now, though. Let's add a move constructor back. Now I'm trying to assign, though, what will happen. Let's see, I think it's going to say that my assignment operator is private. Yep, it's a private member. However, now I call copy, then it's still assigning, but then it's using a it's assigning a temporary, so I should be able to get away with this if I also add a move assignment operator. It's still dirty, you know. Suppose I don't want to have a move assignment and move constructor, but I still want to be able to explicitly type copy and then make a copy. If I do this with like this, and the only thing that I gain is that I'm getting a temporary as a copy. Which is definitely not going to work without the move constructor. It's more like a make a copy form or something. So assignment. The only way to construct a new sample that is a copy of another one is by having a public constructor, I think. Or not. It's a bit fake. Oh, well, who cares? It's a hack, but well, as long as it compiles. Yeah, what now? Okay. 2, 35. 35, and then we make a copy of that, we hope. And then I go until we see 42, 43, 44, and we don't crash. 45, 46, 47. And we never reach a point. It's going closer and closer and closer. What the heck is going on? But yeah, the minus 38 now survives for a long time, so that works. Now I have to find out why it's not terminating. We are looking for a minimum. How is this not a minimum if this step, absolute step, becomes negligible? Oh, this is because the scale is 0. Really, really? Why the hell is the scale 0 then? Scale 0 because the left edge and the right edge are the same. Okay, and why is that? But still two things that are the same. What the heck? Yeah, the scale becomes 0 after adding watch 0.44. Yep. They point to the same symbol. Okay, since minus 38 is part of the cubic, it fits. Therefore, it should always be the left edge in this case. So at some point we lose the fact that the left edge is at minus 38 still. And the only thing I can think of is that it's a floating point round-off error or something. No, it's not ignoring minus 38. It's not there anymore. I suppose I have another pointer, which is not pointing to the new sample, the pivot. I think one of these two should have been minus 38. Yep, indeed. Yeah, I remember. I have pointers in the scale as well, of course. So you have the same problem with the pointers in the scale. You should change those as well then. It's a bit messy. This is really messy. It's too messy. Can update that pointer as well, but I'm not convinced that I'm not convinced that I won't be overriding the pivot later on, while that should not happen in the case of the scale, I think. No, it should not happen. I think it starts to bite me that I'm using sample pointers instead of just making copies of it. Okay, let's see. Yeah, I wasn't looking at chat for a while. Instantly I'm distracted. What was I doing? Oh yeah, I wanted to know where scale is stored. I think in approximation. That's the scale, totally. And then I wonder where the scale is being updated. Here's an update here in update scale, which makes sense. And another one in update local extreme scale, which is less interesting, by the way. That should not be doing backtracking anyway. Okay, those are the only two. So then the big question is how often and from where is this being called? And the other one, update scale. I guess only from here and then also only from there. Or not, there's another one there. After being disconnected. Hier is samples count. Okay, see how often this is being added. Hopefully only from here, that would be best. So I'm going to name that one to add to. That is approximation add. I have a lot of calls to that actually. My God. Cool. here. I don't really want to commit and rename of ad. Just say no, I guess. Yeah, same thing. That's a plus. Why would I even do that? I mean, it's just added. Thought it was commented out, but I'm not going to commit anything. I'm going to eat. I think I'm going to eat. I should, well, I didn't make a decision yet, but I feel like maybe I should just, not deal with the pointer stuff. Just, I don't know, thought it would work, doesn't, so throw it out the window. Especially in the scale. I mean, I'm currently having I'm having a vector here, double-ended vector with sample data, which then already caches the W value because I wanted to micro optimize this in advance. So I use it as a map, but I use a vector because I know the size is pretty small. It's going to be very small. And then I thought, I don't want to, preferably I should even only store W values and not even the sample pointer at all. So I have as many double values in the same cache line as possible, and then the lookup in this vector will be 10,000 times faster than the map for the size that it has. And insertion as well, because I mostly will insert only at the beginning or the end, and it's double-ended, so cost me maybe twice the memory, but insertion should be very, very fast. All kinds of optimization. Well, I never even tested if this is a bottleneck. It's just, I'm crazy. I'm just really making this mistake a lot. And it's my conviction that if you do not do that, so you just code, who cares how fast it is, I'll just write anything as long as it works, and I'll profile later and then optimize it then once it's, I'm convinced that that doesn't work, because then a year later, when your project is finished and you're finally start a profile, it's going to take another year to do a complete rewrite in order to get the optimization in that I built in from the start. So my code is always extremely fast because I design it with fast in mind. And if you postpone that, you're never going to get it that fast. I don't believe that. I'm convinced of that. But it does mean that my designs take way, way longer. So now, you know, while normally maybe say you would take 1 year to write it, then it's going to take me 2 years, and then I have something that is fast. But what if your design is wrong from the beginning? Then you're really prematurely optimizing, because put a lot of time in that optimizing, like twice the time, and then you discover that the whole design is wrong. For example, like I do now in this case. So I even wrote the DE vector thing itself, didn't put that much time into it, but still a day or something. And in the end, it's maybe partially wasted time, because now I think I should not work with the pointers. Now the whole sample is 3 doubles, including this one. So if I change this to store a sample instead of sample data, then I get rid of my pointer. I just have to make a copy of the W, which I already do, and I have to make a copy of the value and the derivative. So then we have 24 bytes here per element instead of 16 bytes. I mean, come on. And then I'm still worried about, you know, like, yeah, but then my W values are 1.5 times further apart. So I'm having more cache lines, so the lookups in my vector are getting slower. And if I insert something in the middle, I have to move 1.5 times that amount in memory, so that gets slower as well. Blah, blah, blah. Well, I have absolutely no idea if this is a bottleneck. I have to admit that. My speed freakness is really getting in the way here. But okay. That being said, there was another reason why I preferred working with pointers, because if I have a canonical instance of sample, meaning does every sample has just exactly one instance, then I can use pointers everywhere to point to that sample, and I can compare samples equal by just comparing the pointer, which is exact. While if I make copies of the samples, then how do I compare 2 samples equal? Do I have to compare all 24 bytes? That's 3 doubles. Do I have to worry about floating point round-off errors? I just don't like code that's comparing 2 doubles. Now it is true that if they are a copy, then I can probably just rely on the fact that the doubles will compare exactly equal, because they are just bitwise copied and bitwise compared. So yeah, probably just works. Moreover, I can just compare them by just the W value and not the function value and the derivative, because for any given W value, the function value and derivative must be the same by definition, because it's just one function. So I can still compare them as fast as a pointer, but then I have to compare the W value. Probably going to work, but I think that was in the back of my mind when I liked pointers more. Anyway, long story short, I think I'm going to, I think I'll convince myself slowly that I should get rid of this pointer. I'll no longer store this, but instead store samples. So you can start with deleting sample data. And that's why I was looking at my git diff, because I consider this a big change. And I don't like to have an uncommitted stuff while making this big change, but the uncommitted stuff is still so much work in progress that I don't want to commit it either. No, okay, let's just do something. So I'm gonna delete this. And then this must be copies. And then all hell breaks loose or not. Sample data. Get nearest sample. This finds in having iterators run over all samples. Passing a sample data. What the hell am I doing here? Data, oh, data sample, yeah, okay. So this is comparing the pointer. But like I just said, I can probably just compare the W value. So my data is now, of course, also being a sample. Maybe I should call it sample then. And current is well, a sample pointer, but that's probably also going to change into a sample reference then. Might as well make that change because it just won't compile if I don't fix the other end as well. If I no longer work with pointers, I should probably use references instead of pointers. W. And then this looks really dirty in my eyes. So I think that definitely requires a comment. Okay, now the iterator changed, of course. So now the iterator is a pointer to a sample. So I cannot no longer return that. It doesn't exist anymore. But the dereferenced iterator is still yeah, maybe I should just return an iterator, I'm not sure actually. So I'm returning a pointer to a sample again. Maybe I should completely get rid of that. If I do that, can I do this? Yeah, it's the same thing. Let's try to just return an iterator. But that is a const iterator then. And I was returning a non-const pointer. Get nearest sample. I'm not sure what I'm doing with the nearest sample, but I can't believe that I want to have this. I can't believe it. On the other hand, I definitely don't want to return a non-const pointer because this vector is ordered. It's just nonsense to want to make changes to it. Maybe all my... yeah, it would... yeah, I don't know. Yeah, this is not going to work, I think. In the end, I want to combine history samples with these scale samples. And then I want to forget where they came from, so I can just pass a sample by reference or by pointer, but not as an iterator. That would not work. Yeah. For now, I'm going to return iterator and then see where that goes wrong. It looks way slower, but it really isn't. This W is just an accessor of a member of whatever this thing is pointing to. So it's still all in the DE vector itself, part of the DE vector, so the same cache line. There's not really much difference, and that is just 50% or 1.5 further apart. And then I'll just return this iterator, these iterators. Oh. Yeah, it's now no longer possible to hide the copy constructor of sample if I put it in a vector. But then again, also this is no longer true because I'm stopping to use pointers, I guess. So now we have just the actually pre-default stuff, so I'll delete everything. Nope, not recorded. It's live. I never brought. I mean, that would be too boring to record and then transit broadcast like this without editing. What to do? I'm trying to fix compile errors after removing sample data. A reference to non-static member function must be called. Did you mean to call it with no arguments? This is now the sample. I sure need to go eat. I'll have a quick run of this and then I go eat. Hopefully it won't crash very quickly. So before crashing at 44 because we were overriding the scale and I got a scale to 0. So now I'm having a 42, scale is not 0, it's 3, so yay, solved. See if we can continue. Success. Now, that's the best moment to quickly turn off my monitoring.